This is Geometry Unit 10, Day 2 notes, working on the volume of prism and cylinders. The volume of a solid is a number of cubic units contained in its interior. Basically, the volume is the amount of three-dimensional space in an object. So if you take a cubed shape, like a Rubik's Cube or a gum that's in a cubic form, you can drop that into a box and you see how many of those would fill up the entire box. That would be your volume. That's a cubic unit filling up the volume of the inside. What two-dimensional shape could you use to build a cylinder? So you need to think about what a cylinder is. It's like a can of soup. And what would make a cylinder? What shape is being repeated again and again and again? But that would be a circle. So if you take one penny and put another penny on top of that and again and again and again, then you're forming a whole bunch of circles that are making a cylinder. Or a whole bunch of lids, circular lids, could form a cylinder. We'll talk about the volume of a prism. Basically, the formula for finding the volume of a prism is the area of the base, which is the capital B, times the height. Now, it matters what the shape is, because the capital B is the area of the polygon for the base. It's the area of the base. So sometimes you'll have to use length times width if it's a rectangle, or you'll have to use half base times height if it's a triangle. You have to find the area of the polygon for the base of your polyhedron. The height. Well, the height, of course, h is the height, but we're going to call it the distance between the bases. Because if the polyhedron is laying on its side, then the height is not up and down. It's not a vertical measurement. It could be front to back. So basically, it's base times the height, where the capital B is the area of your base. The height would be the calculation up and down. Perpendicular. So we're going to take that formula and come down here. We're going to find the volume of a right triangular prism. We called it a right prism because the height, the distance between the base, the two bases, are perpendicular. It's not because it's a right triangle, but it's because if you stood it up on the base, it would be going straight up. So first of all, you want to identify what is the base. The base here is the shape that's being repeated throughout the entire figure. And this would be a triangle. This whole shape is a triangle after a triangle in different units. So our volume is base times height, where in our case, B is going to be the area of a triangle, and H is the distance between triangles. So to calculate out the base, we're going to say half of base times height. Now this base times height is different than the B and the H for the volume. This base times height is the area of the triangle. So to calculate the area of this triangle, the base would probably be considered the 3. The height has to be perpendicular to it. So we get 3 divided by 2. 1.5. That would be feet. So that's the area of our base. Then we take that and we multiply it all the way through. Your height is your distance between the bases, which is 2. So the volume equals 1.5 times 2. And the units would then become cubed, because our area here would be squared, and then another foot would give you cubed. Feet squared times feet give you feet cubed. Another formula we work with, which essentially uses the same formula, is a cylinder. A cylinder is like a can of soup, a pop can. It's the base times the height. Now what makes this one a little bit more unique is that the base is always a circle. So it's always pi r squared, and then you take that and you times the height. So the base is going to be the area of a circle. H is the distance between the circles. And r, of course, is the radius. So for a formula, we get pi r squared times the height. So let's try it here with example number 2. They want us to find the exact volume of this right cylinder. We call it a right cylinder because it stands up exactly 90 degrees. So the 6 is actually considered the height that's perpendicular to its base. So the volume is going to be pi r squared times h. Well, the r of the base is 5. The height is 6. So that gives us 25 times the pi times the 6, which is 150 pi meters cubed, because it's volume again. Area, meters squared, would be the units for the circle, and then multiply it by meters again, gives us meters cubed. Exact means to leave your answers with the pi symbol and not turn that into a decimal to round it. Leave it exact. So if it has a radical or if it has a pi symbol, you leave it in that form. The volume of a right cylinder here is going to be 1,253 centimeters cubed. We're supposed to find the value of x, which is our radius. Well, this is a cylinder, so the volume is pi r squared times h. We know that the volume is 1,253. Notice this time they're not using a pi symbol next to the 1,253. That incorporates all that. Times a height, which is 10. So we'll divide by the 10. You could even divide by the 10 pi if you want to do it all at once. Now we'll divide by the pi. So we get 3988. So from 3988, we'll take the square root, and that'll leave us with 6.32. That would be the square root of 39.88, 6.32. and those would be centimeters. It's a radius, so it's not cubed, it's not squared, it's a length. It's a distance from the center of the circle to the edge of the circle. Now on the flip side, we're talking about something different than a right prism. A right prism or cylinder goes straight up. Well, you could also work with oblique. Oblique means that it's going to be slanted, similar to this figure here. You can see that with the Cavalieri's principle, the figure can go straight up or it can be slanted, and it wouldn't matter which shape that you're talking about, as long as your calculations and values are the same. So if you set a group of coins going straight up, or if you take those group of coins and slant them, or in this case they have them kind of zigzagging back and forth, the volume, the number of coins, is exactly the same. It doesn't change. It doesn't change if you set them in a slanted pattern or if you make them go straight up. But what does change are some of the numbers. The slanted distance is going to be different than what the height was. So to calculate for the formula, you do need to figure out the height. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So in this case, we know that there's this right triangle with 60-degree angle. 18 is considered the hypotenuse. We've learned in the past that for a 30, 60, 90 triangle, the hypotenuse is the short leg times 2. So if the hypotenuse is 18, then the short leg, you're going to divide by 2 to get 9, and that's millimeters. So that's our length of the short side. Now the long side equals the short side times root 3. We don't know the long side, but the short side is 9 times root 3. So we have 9 root 3. Of those numbers, which ones are we looking for? We need to know the height of the figure. We need to know perpendicular straight up from the bottom to the top. That would be the 9 root 3. So remember that the volume of a cylinder is pi r squared times h, where in this case the diameter is 12, so the radius is 6. And the height is our 9 root 3. So this comes out to be 36 times 9 root 3. Well, 9 times 36. With your calculator, you could see that that is 324. We'd still have the pi symbol, and then we'd still have the square root 3. That would be considered our exact value, and this is millimeters cubed. The next shape we see down here is a rectangular prism. When you look at the rectangular prism, you can't really tell where the bases might be. If they want to call the side the base, or if you want to call the side the base, that would be 5 times 4. That's the base is 20. Most likely, in a figure like this, you would call the base the 11 times 4. And then you would multiply that times the height. whichever format you want to use. 11 times 5, the front of the box, towards the back. However you want to think about it, you would end up getting the same result because it's just the same three numbers multiplying each other. So volume equals 11 times 4 times 5. That's 220 meters cubed. This is an obvious way that you can see m times m times m gives you m cubed. The area of the bottom is m times m, m squared, and then to multiply the top is an additional third m. Find the exact volume of a right cylinder. So they're telling us that this is standing straight up and down. So we know that the volume of any cylinder is pi r squared times the height. They give us the radius. They give us the height. And we know what 36 times 9 is. So we get 324 pi. The units are feet, and because this is volume, you need to be sure to say feet cubed. Here we have a triangular prism. It's considered oblique because it is slanted to the side. But if you look at the numbers they give us the actual height. We don't have to calculate it. It's possible they'd give it to us with a 30, 60, 90 triangle, a 45, 45, 90 triangle. They could also have us use SOHCAHTOA, which would be sine most likely, or even cosine. So we're going to find the volume of here. Well, the volume equals the base times the height. The base of this shape is a triangle. So to find the area of the triangle, we're going to say half of 9 times 5. And if you look here, the 9 and the 5 are perpendicular to each other. So they are bases and heights. We don't have to worry about trying to calculate a perpendicular segment. They are perpendicular to each other. Heights have to be perpendicular. Now that's just the height of the triangle. That's the perpendicular measurement to the 9. So now we're going to take the height of our prism, which is perpendicular from the bottom to the top, which is 8. So we have half of 45 times 8. You could take half of the 45, you could take half of the 8. I'm going to take half of the 8. Now I know that 2 45s make 90, so 2 more 45s make 180. These are meters cubed. Last one. We're going to find what the value of x is, which is the diameter of this cylinder. They give us the volume of the right cylinder, meaning that it's standing up straight. Notice that in their answer for the volume, they do give it to us in terms of pi. So I know that volume equals pi r squared times h. Well, the volume is 200 pi. I don't know what my radius is, but my height is 8. So I'm going to divide by 8 pi, so the 8's cross out and the pi's cross out. Over here I'll say 8 pi. So 8 goes into 200. There are 8 quarters. 8 times 25 is 200. And only the r squared is left on this side. So we'll take the square root of both sides. So we figure out that r equals 5. The radius is 5, but that's not what they're asking for. We know that the diameter equals 2r. So the diameter equals 2 times 5, which is 10, and the units are centimeters. So they're not squared, they're not cubed, because diameter is a length. It's from one side of the circle to the other side of the circle through the center.